You are told the vertices of a triangle are given as, so the vertices means these endpoints. So if you got 3 points, that's your triangle. So these are the vertices. So here, specifically, we are dealing with a right angle triangle because we are told that BO prove that the value of x is equal to root 2 if BOC is equal to 90 degrees. That means this point here, O, that's the angle 90 degrees. Okay, so you are told that O is the center there, which is 0, 0. That is O. Okay, then you have another point, B, which is square root 2, x is square root 2, and y is square root 2. So, but what is square root 2? So we need to have an idea. You see, I'm going to put this here. Square root 2 is like 1.4. Right, so when x is 1.4, y is 1.4. Let's put it somewhere around. Okay, just a rough sketch. So let's call this point here B, which is root 2 and root 2. Okay. Now, if I join these two here, if I do this, if I draw a line here, now I need to get this point C. Okay. The problem is I do not know what the x value is, but I know what the y value is. Okay, what is the y value? Minus 2. So if that's minus 1, minus 2, so maybe minus 2 somewhere around here. Okay, so that is your value, minus 2. But now, so let's put it here. Why am I putting it there? Is so it looks like a right angle triangle. Okay, so I'm going like this here. So that is my C, which is x and minus root 2. Okay, so minus root 2 is minus 1.4. So I'm just drawing my point here. I'm taking a guess. It could be, but definitely minus root 2 is down here. It's just that I'm not sure what the x value is. See? Okay, but obviously we need to prove it in the next step. But can you see the way I'm drawing this triangle? So now if I take my ruler and I do this here, so here is my 90 degrees now. Can you see that? It looks like a right, it's not 100% perfect, but it looks like 90 degrees now. Can you see that? Right, so now prove that the value of x is equal to root 2 if BOC is equal to 90 degrees. Okay. So what do we understand now? If BOC is equal to 90 degrees. So there's my BOC here. Okay. So what do we understand by that statement? We are given. We must use this information here. Okay, we are not proving that it is 90 degrees. We are told that it is 90 degrees. Okay, so we must use the fact that it's 90 degrees. So we are given BOC is equal to 90 degrees. So what does that mean? It means BO. So therefore, BO is perpendicular. Okay, so your BO is perpendicular to which line? To OC now. BO is perpendicular to OC. Because if BO is perpendicular to OC, that means they intersect at 90 degrees. And if they intersect at 90 degrees, that means the gradient of BO times the gradient of OC is equal to what? Negative 1. You see, those are all the facts that come from there. So therefore, BO is perpendicular to OC. So therefore, the gradient of BO times the gradient of OC is equal to minus 1. So that's all the information that we can deduce from the fact that BOC is 90 degrees. Okay. So what can we do? what can we do here? We got points. You can see we got 2 points here. We got 2 points there. We can use this factor that m of BO times m of OC is equal to -1. Okay. So alright, so which one are we looking for here? We are looking for this x value there. Right, so the gradient of a BO. So let's just write down that's O and B, which is √2. Okay, so if I want to work out the gradient of OB, so I'm going to go m of OB, that's going to be y2 minus y1 over x2 minus x1. So my y2 there is √2, my y1 is 0, x2 is √2, x1 here is 0. So therefore m of OB is equal to √2 over √2, which is equal to 1. So the gradient of OB is 1. Okay. Now, what is the gradient of OC? So we got O, and then we have C. C is the one with the unknown variable there, which is x and minus √2. Okay. So the gradient of OC, there is going to be y2 minus y1, which is minus √2 minus 0 all over x2 minus x1 there, which is x minus 0. You follow what I'm doing? Just working on the gradient. Right, so now we have minus √2 over x is equal to the gradient of OC. Okay, but now, what do we know? Okay, what do we know? We know that m of BO times m of OC is equal to what? Is equal to -1. Okay, and what do we already know? We know that m of OB is equal to what? 1. So 1 times m of OC is equal to -1. So what is the gradient of OC equal to? So the gradient of OC is equal to -1 divided by 1, which is -1. We're clear with that? So now this information here, I can substitute it here now. Can you see that? So I know that m of OC is -1. So -1 is equal to minus √2 over x. And now all I have is one unknown in this equation here. So if I cross multiply here, -1 times x is equal to minus √2. So x is equal to minus √2 divided by -1, which is √2. And that's what was required here. To prove that the value of x is equal to √2. Maybe there's a shorter way, which I didn't see at the moment. It seems like it was a bit long here. Maybe there's a shorter way, but the fact is, I'm just using the fact that the lines are perpendicular. And we proved it, you can see this. Alright, so that was that. The next question, let's just finish this quickly, alright? Determine the perimeter of, oh, this one is 4 marks now. Determine the perimeter. Perimeter. So, how do we work out the perimeter? So let's say if I have a triangle like this here. What is the perimeter of this triangle? Perimeter means if you start at this point here and you go along the edges, you walk along the edges of this shape here, and you come back to the same point, what is the distance that's measured? From the point you start, from this point that you started at, and right until you came back to that point. So from here to here is 4, plus from there to there is 3. From there to there is equal to 5. Okay. So basically the perimeter is the distance along the edges along all the edges, okay, of this object. So 4 plus 3 is 7 plus 5 is equal to 12. So basically what do we need in order to find the perimeter? We need the distance from there to there. We need the distance from here to here. And we need the distance from there to there. So we can add up all the sides. Okay. So how do we work out the distance? We can use the distance formula. Okay. I'm just going to use the distance formula for everything here. Alright. So the distance here, the distance formula is x2 squared plus, sorry, it's a minus there, correct? So minus x2 squared minus x1 squared. No, I'm making a mistake. It's x2 minus x1 all squared plus y2 minus y1 all squared. Am I correct with that? That's the distance formula. Okay. So the distance from O to B there. So let's call this point here x2. So that is y2. This one will be x1, y1. Okay, nothing difficult about this here now. So what's good about this question is even if you did not work out 4.2.1, they still gave you the answer, so you must go and put it in there and then use it to answer the next one. You follow? So even if you got that wrong, it doesn't mean you're going to get everything wrong. You can still work out the next one. This is the one that was missing. Remember, this is the one that we worked out now. Alright, so distance formula, again, there's not much thinking, it's just to substitute, use your calculator and work it out. Alright, so let me go x2 minus x1, so that's going to be 0 minus root 2 squared, y2 minus y1 there, so that's 0 minus root 2 again. So that's minus root 2 squared, which is 2, minus root 2 squared, which is 2 again. So we get the square root of 2 plus 2, which is 4. The square root of 4 is 2. Okay. So this distance here is 2 units. Okay. The distance from O to C when you square, the square root of 2 squared is what? It's 2. Okay. The square root of 2 squared is 2. The square root of, even if it's a negative, the negative squared will still be positive there. So 2 plus 2 will give you 4. The square root of 4 is 2. Okay. Alright, so I'm just going to do OC very fast. So that's good. I'm going to go that minus that. So I'm going 0 minus root 2 squared plus 0 plus root 2 squared. So that's going to be minus root 2 squared is 2. Root 2 squared again is 2. So the square root of 4, which is equal to 2. So therefore, this here is 2 units. Also, can you see that? So these two sides are equal. Okay, that means it's an isosceles triangle. I can see that. These two sides are equal, it's an isosceles. This is 90 degrees. These two angles must be equal. These two angles add up to 90, so this must be 45 and that must be 45. Just for your information. Okay. What about the distance from B to C? the distance from B to C. Okay. Now, I'm not going to use a distance formula for this one because remember that it's the same x value. Okay. It's the same x value. What am I saying now? Let's see. This one here was root 2, and this one is root 2 minus root 2. Okay. I'm talking about the distance from B to C. So we know that the distance from here to here, if you're going from there to there, what is the y value? It's root 2. And the distance from there to there, going down, is also root 2. It's just that it's on the negative y-axis, that's why we label it as negative. But the fact is, this is root 2 and that is root 2. So what is the total distance from there to there? It's going to be root 2 plus root 2. So therefore, BC, the distance BC is equal to 2 root 2. So your perimeter is equal to, you add up all the sides there, so that's going to be 2 plus 2 plus 2 root 2. So 2 plus 2 will give me 4 plus 2 root 2. They just asked us to work out the perimeter, not prove anything here. They didn't say do not use a calculator, so we will use a calculator. Give me the answer rounded up to 3 decimal places there. 6,828.